Good day, everyone. I'd like to share with you the topic, which is all about the discovery of atom, ions, and isotopes. The discovery of the atom by Joseph John Thomson was about the electrons and the protons. He discovered that the atoms have negatively charged particles, which he called electrons, and led him to propose a new model of the atom called the Plum-Pudding model. So as you can see on this figure that the ball of positive charge is around, okay, the atom, while the negative electrons are embedded or are inside this positive charge of ball. So this is again the Thomson's plum pudding model of the atom. The discovery of the atom by Ernest Rutherford, Johannes Hans Wilhelm Geiger, and Ernest Marsden tested the atomic model of Thomson by means of bombarding a very thin sheet of gold foil with positively charged alpha particles. Their experiment is referred to as the alpha particle scattering experiment. As a reference is a figure on the left side, as you can see here that the box is beaming a light. That's an example. It's color blue. That's actually towards the gold foil at the center. So this is the gold foil or the thin sheet of gold foil. As you can see that the light directly hits the gold foil, and the light scattered in many directions. Of course, it is surrounded by a detector of the fluorescent screen. Now, when the light actually pass through, there are alpha particles that are undeflected. So that's the first observation, or the general, in terms of the general conclusion. The first is most alpha particles were undeflected. So it means that the beam of light, most of them pass through in straight line. The second observation or conclusion is that some are deflected. Some are deflected at smaller angles. So it means to say that they're deflected in partial angles. So as you can see there that there are alpha particles that are not in straight line anymore. So the third observation or conclusion is that few alpha particles deflected almost back towards the source. So the deflected particles that are so few or deflected, means to say the word deflected is it means bent, or in the past tense bent. So it deflected almost towards the main source. So as I mentioned, the fluorescent screen is a kind of a detector that when an alpha particle actually hits the center of the gold foil, so it means that it's an indicator that the center of all the particles of the gold foil has very has a hard part or a dense part. Okay, and later on they called it the nucleus. So let me continue on the next slide for this explanation. This figure is a close-up of the Rutherfords model of the atom. as mentioned earlier, that the most of alpha particles did not bend, okay, or bent. So it means they go straight, okay, as in this indicated in this figure. That if you notice, there are four arrows. Okay, so these arrows are the alpha particles. Okay, so if the alpha particles go straight, based in their on their observation that these are the electrons, okay, part, okay, that that's why it goes straight. However, for those alpha particles that hits the center in a partial hit, okay, so it also bent a little. Right? So as you can see, it's scattered a little. Okay, so you have here an example one only, and the few one of the third, okay, or last one that were mentioned is the or was the bent of total bent of the alpha particle almost goes back to the main source. So if the arrow that indicates here hits or the central part, okay, so it means the nucleus or the dense part. So that's why it's deflected or bent. Okay. So that's the indicator that, or that's the main purpose of this experiment, or this gold foil experiment, that if the alpha particles pass through, so the atoms, or the smallest particle of all the objects, okay, that we have, or all matter, have the electrons, or the part where there's a less, it's a less dense, okay, part, while the one that's actually heavier, or more dense, or denser, it means that it deflects the light, or it goes back the light. So it means it hits something that's hard. So they call that, okay, central part. So it's a proof. Okay, it is a proof, or it proves to us that that the atom has these particles inside. In continuation of the discovery of atom by Ernest Rutherford, it is called the nuclear model. So he suggested a different structure of the atom where all the positive charge and nearly all the mass of the atom were concentrated in a very tiny region called the nucleus, which is found at the center of the atom. The rest of the atom, where the tiny electrons with very small mass moved, was largely empty space through which the alpha particles could travel undeflected. So as you can see here, on the left side is a figure from Encyclopedia Britannica Incorporated. So this is the central or the center of the atom. It was zoomed. So you have there the nucleus. Okay, so it's composed of the protons and the neutrons. So the electrons are around it, okay, so surrounding this nucleus, or revolving around it. So it's why it's called the nuclear model of the atom. Alright then, so after learning about the history of atom, or the discovery of the atom, let me share with you about how we can get the number of protons, electrons, and neutrons. So you can have a reference about this by looking at your periodic table. So here is an example of an element, helium. You can see in this figure what is an element. Okay, so you will see the symbol of helium. Okay, so you have the first letter, a large or capital H, okay, and second is the letter E. It's a small one. So if you notice in your periodic table that the elements symbols are actually starts with the capital letter. Okay, and you have here the uh, full word of or full name of this element. You have helium. The atomic mass. Okay, so sometimes they are at the top or bottom of this name of the element. So here we have helium has atomic mass of 4. And so it depends on the kind of periodic table you have. Just look at the legend or indicators. Okay, if they are at the top or at the bottom or on the top left side, okay, or right side of it. And the atomic number, okay, of helium is 2, as indicated here. Below that is the structure, okay, or the atomic model of helium. Okay, so you have there at the central part or the nucleus 4 of them. Okay, so that's the atomic mass 4. Okay. So you have the protons. Okay, as remember, that's at the center of the or this nucleus or the subatomic particles are the neutrons. Okay, so the zero charge and the protons. Okay, so you have the positive charges, and surrounding that you have the 2 electrons. Okay, of the helium, right? So that actually makes the atomic number. Okay, a single atom is said to be electrically neutral if its number of electrons, symbol E negative, is equal to the number of protons P positive. So what does it mean? Okay, that in neutral, okay, or regular atom, for example, okay, here we have helium. Take a look at the atomic number. The atomic number is 2. So it means that the electrons of helium is 2 and the protons of electron is also 2. Thus, the atomic number, okay, of an element also specifies the number of electrons in neutral atom, as I've already mentioned. So mathematically, for a neutral atom, okay, Z is equal to P plus equal to E negative. Okay, so it means Z, okay, or the atomic number is equal to the number of protons positive. It's also equal to the number of electrons negative. Since the mass of an atom is concentrated in the nucleus, the mass number is designated as A, is equal to the sum of the masses of the protons and neutrons. So how do we get the mass number? So aside from directly looking at your periodic table as indicated there, for example, helium, you have atomic mass number 4. So we can also get it by the sum of the masses of the protons and neutrons, right? So as you can see here below, in the atomic structure, you have 4 of them. Okay, so it means that 2 electrons, oh no, two protons and 2 neutrons, and the electrons is around it, 2 of them. All right. So I hope you got everything. How to get, okay, remember how to get the neutral or the regular way of getting the electrons, protons, and neutrons of the atom. That includes also the mass number. Let me share with you an example here of how many protons, electrons, and neutrons are present in boron 11,5b. What does it mean 11,5b? So 11 is the atomic mass number of the atom boron. okay, you have 5. Okay, so the 5 there is the atomic number, and B, that's the symbol of boron. Solution, you have the mass number as indicated, A is equal to 11, and atomic number, you have the symbol or here indicated Z, you have 5. So since atomic number or Z is equal to number of protons, P positive, is equal to the number of electrons, E negative. So that's actually the one that I've explained a while ago. So how many protons do we have? P positive is equal to 5. Now how are you going to get that again? By looking directly at your periodic table. So look at the atomic number of boron. So boron has 5, and of course, since it's 5, it's the atomic proton of this is also 5, and the electron of that is also 5. Now how about the neutron? So in terms of neutron, okay, mathematically you have to get it by making the number of neutrons or zero charge is equal to A minus the protons, P positive. So since we have in this example, boron has 11 mass number, minus or subtract that to 5 or its atomic number, so you get 6. Okay. So you have also here on the right side the atomic structure of boron. Okay, so as you can see there are how many electrons? 5 around it. So that has color blue. Okay, so you can see it clearly. And for easy reference, look at the central part or the nucleus. Okay, so this nucleus or nucleons, you have 5 protons there, and that's color red, and 6 neutrons. Okay, so that's color yellow. Right, so in all, okay, again, okay, so to get the number of protons and electrons, just look at the atomic number, okay, of the element. So for boron, since it's 5 atomic number, you have 5 P plus, and negative electron is equal to 5 also. To get the neutron, as I've mentioned earlier, you have to subtract that by 11, or the mass number 11, and atomic number 5, that makes 6, right? Alright, so what are ions? Okay, so ions are actually charges, okay, of atoms. So atoms may gain charges. This happens when electrons are lost or gained by the atom. So when this happens, the atom becomes an ion. So a negative charge, ion, or known also as anion, has more electrons than protons. The net charge of the ion is the difference between the number of protons and the number of electrons. What does it mean? That we have to subtract the number of protons, okay, protons minus the number of electrons. Okay, so what do we get? The net charge of the ion. So for example, a neutral lithium atom has atomic number 3. It has also 3 protons and 3 electrons. So take a note that this is getting the atoms. Okay, so it's the same thing that I've actually explained a while ago. Okay, so if what is the number of the element, or the atomic number of the element, that's also the number of equal number of the protons and electrons. But here in the ions, it can actually gain or lose. Right? So if the atom, for example, in this table, if the atom loses 1 electron, it becomes an ion, or also known as cation, with a charge of +1. Okay, so you can compare in the table. Okay, you have the comparison of lithium atom and lithium ion on the right. So let's take a look at that. Okay, or let me explain this for you. So number of protons positive in the lithium atom plus 3. In the lithium ion, it's the same, plus 3. The number of electrons, negative, lithium atom, negative 3. So the lithium ion becomes negative 2. So the net charge is 0 for lithium atom, while for the lithium ion, it's plus 1. So why it happens that the charge is plus 1? Because it loses 1 electron. Take note that lithium ion or lithium atom should have plus 3. Since it loses 1, so that's why you have 3. Okay, subtract that by 2 and it becomes plus 1. Okay. So the symbol for the lithium atom, Li, okay, no charge. Okay, so if you see that in the element, okay, if the given is actually 0 or no charge, so you don't see any positive or negative charges or symbols. While for the lithium ion here, example, since it's the net charge is positive 1, okay, so you can see there lithium Li symbol and then plus 1. Sometimes you can only write Li and then plus. Okay, so no need to put the 1. So it's already um, no, okay, or indicated as plus 1. Okay, so let's have the um, example, okay, at the top of the table. Okay, you can see this figure, okay, of for example, an example from the periodic table of the elements. Okay, so how you can see the charges easily, okay, aside from the making table, okay, as I've explained earlier. So you can also take a look at the periodic table directly, and the superscript at the right denotes the charge of the ion, so wherein the number of electrons may be determined. All right, so as I've told you, okay, a while ago, that it depends on the kind of periodic table that you're using. So you just study very well the indicators of your periodic table. So where's the location of the mass number, of the atomic number, and the charges. So the charge here, okay, for example, if the charge is 0, when there is no superscript shown. So if there's no charge, okay, so you cannot see any positive or negative charges there. Okay. So here lithium, okay, mass number 7, atomic number 3, and you have the charge plus 1. Okay. So please don't forget that when the electrons are lost, okay, or gain the atom, it's called the ions. Okay, it becomes an ions. So a negative charge ion is also known as anions, and it means that it has more electrons, okay, than the protons. And it's opposite if you have the loss of one electron, so it becomes the so-called cation. Okay, so with a charge of plus 1. All right. Okay, let me share with you another example here. Determine the number of protons, electrons, and neutrons of fluorine ions. So you have there 19, 9, F, negative 1. So it means 19 is the atomic mass of fluorine, 19. Then you have 9 there. It's the atomic number of fluorine. Negative 1, it's the charge of fluorine, and you have F as its symbol. Solution, given you have A stands for the mass, 19. You have the Z or Z equal to 9, that's the atomic number, in the charge of the ion is -1. Okay, so as I've explained earlier, that if the ion is -1, it means it gains 1 electron. So the number of protons, P positive, is equal to 9 as indicated. Okay, so as you've learned already that to get the protons, you just have to look at the number of or the atomic number of the element. How about the electrons? Since we are talking about ions, it's not the regular number of atoms. So you have E negative. Okay, so you have 9. So 9 plus 1. Okay, because it gains 1 electron. Okay, so it gained 1 electron. So you have 9 plus 1, that becomes 10 electrons already. So the number of neutrons, okay, so we just follow the same procedure. Okay, so if the given is 19 for the mass, you have to subtract that by the atomic number. So 19 minus 9 is equal to 10. All right. Now, this is for fluorine. Okay, so I hope you're getting the clue or the knowledge of how to get the number of electrons if we are talking about ions. Okay, so if it gains or it lost electron. Okay, so again, remember that for the ion that actually -1, okay, so it means that it gains 1 electron. But if it is positive, okay, so it means that it's actually -1 electron. All right. All right, so let me explain to you about isotopes. So isotopes are atoms having the same atomic number but with different mass number. So what makes the three isotopes of hydrogen different from each other? So in the table, you have their element. Okay, so if, for example, the hydrogen 1, okay, so hydrogen 1, it means the name of this element is protium. H2 or hydrogen 2, you have deuterium, and 3, H3, tritium. So atomic number, as you can see here, they're all the same 1. Okay, so if the atomic numbers are the same, the element also is from hydrogen, although you have there the differences in mass number. So the mass number of protium is 1, and deuterium is 2, and tritium is 3. So that makes the differences of the mass number. So it means this belongs to isotopes. Right? So protons positive. Okay, you have the same number of protons. Okay. So atomic number is 1 for this hydrogen or for this hydrogen isotopes, and you have, of course, the same number of protons there with positive 1. Now let's take a look at the neutrons. Okay, so neutrons, okay, so you have 0 for the protium. Okay, so you have the neutrons for deuterium 1 and proton or neutrons of tritiums 2. Now, so let's take a look at the electrons. Electrons, okay, negative. So all of them are also 1. Okay, so why? Because the atomic number is 1 of hydrogen. So it means all those isotopes have the same number of the electrons and the protons. Okay, what about the neutrons? Why there's a difference, okay, in the number of neutrons? Because as you can see that in the formula or getting the number of neutrons is by subtracting the mass number, okay, by the atomic number. Okay, so For the H1 protium, 1 minus 1, okay, that becomes 0 charge there for the neutron, so or 0 neutrons. Okay. So we have deuterium, so you have 2 minus 1, that's 1. Okay. So tritium, you have 3 minus 1, that becomes 2. Alright, so I think this is very clear to you. Okay. So please focus well about the mass number. So once there's a change in the mass number of the element, it means that you are referring to isotopes. And the neutrons also have differences as the atomic mass number increases, because they have to follow the process of getting the neutrons, mass number minus atomic number. However, the atomic number, the number of protons and electrons are the same. Alright, so different isotopes can exist, and this can be identified by its respective mass number. So the mass number is the sum of the number of protons and the number of neutrons in an atom, as I've already explained. So for example, tritium H3 has a mass number of 3. So referring that to the table that was used a while ago, or from the previous slide. Its number of proton is 1 and 2 for neutrons, giving a total of 3. Okay, mathematically, mass number of tritium plus positive or proton, and then plus the number of neutron. So you have 1 plus 2 is equals to 3. And the isotopes here for the carbon, as another example, you have carbon 12, 13, carbon 14, and the number of the atomic numbers is actually 6. As I've mentioned, that it's the same for the number of protons and electrons, it doesn't change. But how about the neutrons? So you have to take a look at the mass number, subtract that for the atomic number. So you have there 12 minus 6, that will be 6. Okay, 13 minus 6, that would be 7, and 14 minus 6, that would be 8. Okay, so let me share a practice of getting the isotope number, the element, atomic number, mass number, protons, electrons, neutrons, and the charge. As you can see here, the highlighted are the given in this table. However, those not highlighted are the answers. Okay, so this is only a practice, okay, for your guidance. So if you already know very well, okay, how to get it. So in the isotope numbers, okay, this is only the first level. I did not make any second level, like for example for carbon. So there should be like carbon 13 and carbon 14. So I did not use that, so instead only the first level for all of the isotopes. So that also makes sense in getting the number of neutrons later on. Okay, so C12, okay, the number or the element name is carbon. Okay, so atomic number 6. Okay, mass number is also 12. You can see that directly at your on your periodic table. Okay, so please study very well the locations or the indicators, okay, of your periodic table, okay, so that you get to know very well the correct answers. And the protons, okay, you have 6, and electrons you also have 6. Okay, so this is just the regular, okay, number of getting the protons and electrons, okay, because the atomic number is 6. Okay, so of course the electrons and the protons is 6. Okay, so how about the neutrons? Yeah, so that's also 6. Okay, and the charge is 0. Okay, so why do you have electron 6 there? Okay, it doesn't change because take a look at the charge of the carbon that's indicated there. It says that we have to put a 0 charge for the carbon there. Okay, no charge at all. So that's why it's 6. So let's have the second one. Okay, aluminum 27. This is the mass number. So you can indicate that there. The mass number is also 27. Atomic number, look at your periodic table. You have 13. Aluminum is the name of the element. Okay, so how do we get the protons? Okay, so look at the atomic number again. That's 13. And take a look at the charge. Okay, so the charge, okay, is positive 3. So again, since it's positive 3, so it means that the electrons will be 10. Okay, so it actually loses, okay, it loses 3 electrons. So you have, instead of the 13 as the electrons, it will become 10. So how do you get the charge? Okay, just take a look at the electronegativity, or the charge of the element in the periodic table. Alright, so the neutrons is actually 14 there. Why 14? Because you have the mass number 27, okay, and subtract that by 10. So next we have calcium. That's the name of the element. Okay, calcium 40. So atomic number is 20, mass number is 40. So protons, okay, so you have 20, and the electrons is 18. So why do we have 18 electrons? Okay, so instead of having the 20, because the charge is positive 2. So you take a look at your periodic table again. So positive 2, so it means it has to lose actually 2 electrons. That makes 18. So neutrons is actually 20. So why? Because you have to subtract that, okay, the atomic mass by the atomic number 20. So that's the same thing, I guess I mentioned, I think, earlier about the aluminum. So you have atomic mass number 27 minus 13. Okay, so that makes 14. So next, okay, you have gallium 70. So atomic number 31, again mass number 70. So you have number of protons 31. Okay, electrons, you have 28. So why 28 again? Because look at the charge of gallium there in the periodic table. You have positive 3, so that makes it 28. So subtract, okay? So you have to lose 3 electrons. And so the number of neutrons is 39, so 70 minus 31, okay, of mass number 70 minus atomic number 31, so you got 39. And the last, selenium. So you have selenium 79 for the isotope, atomic number 34, mass number 79, and protons 34. So where do we get that 1 from the mass number? Of course, in the periodic table. And the number of protons, the same from the atomic number, of course, that's correct. And electrons, you have 28. Yeah, so 28. Why? Because instead of the 34, it subtracted 6, or it actually loses 6 electrons, okay, as the highest for the charge. And the neutrons is 45. So 79 mass number minus that for the atomic number, it's actually 45. So what do you notice a lot in general? Atomic number, okay, for all of that, okay, and compare that to protons, they're all the same, okay, didn't change. In terms of the mass number in the isotope, if you take a look at that first level isotope, they're all the same. 12 for carbon, 12 mass number. So even if you don't look at the periodic table, it's already given there for the isotope. Okay, there you go. If the isotope is missing, so to take a look at the mass number of aluminum, so 27, so that would be Al27. So how do you get the Al? So the symbol. So that's why I told you you have to be familiar. Even if you don't look at the periodic table, you can answer it. All right. How about the neutrons? How do we get the neutrons again? So subtract from mass number to the atomic number. All right. And you only have the changes in the electrons because we are talking about the charges. charges. Okay, since there is a charge here in this table, so it means we are referring to or talking about ions. Okay, so how many charges? Okay, so this is not the neutral. This is not regular. This is not the regular one that for how many if the number of or if the atomic number is 6, so that will be the electron is also the same with the protons. No, so that's why the electrons changes. Okay, so because of the charges indicated in the in the given. Okay, so thank you so much. Okay, that actually ends for this discovery of the atom and how do you get the number of protons, electrons, neutrons, charges, and so on. Thank you very much, and hoping that you have learned okay so much for this lesson. Yeah, so the contents of this lesson is about the history of or the atomic model. Okay, the history or the discovery of the atomic model. You've learned about the ions. Okay, how do we get the number of ions based on the charges, especially for the electrons. Then you've learned about how to get the number of protons, electrons, neutrons, and the mass number of the element based of course looking at the periodic table also, and aside from that, if what is given in the problem, so you can easily get that if you are familiar with the periodic table. So the third that you have to learn a lot is about the isotopes. Okay? So that's everything for this lesson. Thank you so much.